All right, so first we'll sit CSTN 283, building energy efficiency. Let me get, you guys aren't seeing, duplicate. Okay, that's better. So today is, what is today? April 12th. You are correct. Good answer. Everybody gets a point. John Freer, CSTN 283, Building Energy Efficiency, Missoula College. And today what we're going to do is just basically talk a little bit about sealants, because everybody's working on their air sealing projects. And the next part of that is the applied part of it, where we're actually going to get out there and do some of the work. So we're going to talk about different types of sealant and just some basic proper use. And then we'll head out and we'll be doing some demonstration, and everybody will get a chance to do some work with the foam gun and some of the different sealants, so you can actually get a little bit of a chance to try it before we head to someone's actual home and make a mess. We'll make a mess here, and you'll get your practice in, and then we'll move on. So before we get started, just a quick question on the project. Gary asked what exactly are you looking for, and I specifically didn't give you a template because I didn't want it to be a fill-in-the-blank project. The whole concept was you look at the home based on the information that we've covered in the class. Your group makes judgments on what you can and can't do, makes suggestions and recommendations as if you're a weatherization company trying to do it. That being said, there's not a specific format. I'm not looking for font type and number of paragraphs or anything of the sort, but I think you should make sure that you cover all of the tactics and the techniques and the areas that you're looking at doing for energy improvement and air sealing, and that can include, but might not be limited to, actual physical air sealing, bringing in more insulation, bringing in different types of materials, homeowner education, anything and everything that we've talked about that's going to have a positive impact on energy usage, reducing the energy usage for the home.
So you want an essay form instead of just like a Excel worksheet? Well, just hit the...
If you want to put it into a spreadsheet and then put some data behind that as to what, and again, think of it as you're handing this to a homeowner who hasn't sat through this class, who may not understand all the concepts that we're talking about. So if you tell them you're going to spend $150 to do something, why are you doing it? Does that make sense? So have your for better or worse, the term, have your menu of weatherization and energy improvement items, and then have your supporting narrative with it. Does that make sense? Does that answer the question? Yeah. I would not imagine that if you took, and again, based on the budget that we have, we're certainly not going to replace all the windows and do a lot of different things. So I would imagine that if it took you, it shouldn't take you more than about 3 pages to really put a solid narrative with your proposal. Does that make sense? So, and if I certainly wouldn't tell you or stop you from adding more information, or if you want to put any kind of supporting documentation with it, sure, go ahead, but don't. The point of it is not to get some neatly packaged written formal proposal from you. The point of the whole thing is for you guys to think about, okay, what are the things that make the most sense, and how can we put them into play? There's no grading on grammar and spelling, or that's not the point of this. Obviously, if you write it in crayon, it won't show your professionalism. So, Any other questions on that? Does that answer that question and make sense? Okay. Let me just make sure. Yep, we're rolling. So basically just going to talk today a little bit about when and if it comes back up, a little bit about sealant. I won't do that again. The computer's scaring me today. A little bit about sealant, what type we're going to use and why. A real simple short history of where and why this stuff comes from. For the previous 1,000 years or so, we did use sealant in various types in our buildings, everything from mud and straw chinking in between stones and logs to animal bitumen and asphalt and all kinds of other materials. And it really wasn't until the 30s when the whole chemical industry and the polymer industry came about that we started to learn that we could make things that were a lot better than that. So 50s and 60s were all the sulfides and the urethane sealants, and then we found out there were some nasty things in those. We still use urethane sealants, but not the ones that have urea formaldehyde in them. And a lot of it was pushed because of the green building movement, but in the 90s we started to see a lot more effort, energy, and research get put into sealants, both to change the chemical compound so that they weren't as toxic, so they didn't have as many VOCs in them, and then also to find ones that had far better performance. Just a little point of discussion, and if you get into a room and you're talking with a bunch of weatherization guys, oftentimes caulk and sealant are used interchangeably. The big difference is that caulking is really actually a lower grade or intermediate grade product, fairly limited performance, limited shelf life, and we use caulking for things like filling in nail holes and filling in cracks on the interior of our house that we're going to paint. Let me get rid of that. And the other big difference is a lot of the caulkings, they are low quality products, so they have a pretty limited lifespan. They're only good for a couple of years. I'm sure that some of you have seen in all products, there's higher quality and lower quality ones, but a good example is always bathroom caulk. If you go into a house and you see the caulking between the bathtub and the wall or the bathtub and the tile, and in a lot of places it seems, a lot of houses, it's always pulling out and cracking out, and it's usually because they didn't use a good sealant, they used just a cheap caulking. So it wears out. So the term sealant, and this is what we talk about when we're talking about air sealing. We're not talking about putting in a cheaper product. They're usually more expensive. They're usually designed specifically, and we've got some that we'll look at when we're out there today and talk about the differences between them. But the biggest thing is that they're made to last. You don't want to go through the process of air sealing and have to do it every 3 years. A really good high-quality sealant is going to last for 10 years, 20 years. There are ones out there that are advertised as 40-year and 50-year caulking. I haven't been in the business long enough to know if they actually last for 40 or 50 years, but they're out there and they do promote them as such. And the difference is usually the cost difference is there. You can see it. You might pay $3 or $4 for a tube of caulking that's a latex base, and we'll talk about all the different kinds. But you're probably going to pay $6 to $10 for a sealant. And in the grand scheme of things, when you talk about a project, the difference between that on an entire house might be $100. but it's a significant difference when it comes to performance. How do we rate it? Who sets it? It's American Standard Tested Material C90. It's just another standard that is used to compare different sealants through the various properties that they have, and the ones that they compare and rate sealant on are movement capability, sealant hardness, tack time, and adhesion, and so I'll go through those really quickly. And this one's a pretty important one when it does come to air sealing both in new and existing construction, is the movement capability of a sealant. And based on the chemical compound and the material that's made out of, some sealants have more ability to flex and to move than others. We'll talk about a few of those in a little bit, but they're rated in this classification, and it's plus or minus in a percentage. And so that percentage is the ability of a sealant to expand, and the minus is compress. So if you've got a 12.5% movement capability, it's probably not a sealant that you're going to want to put into a joint that has dissimilar materials, because if you have materials, and especially in a house, ones that expand and contract, and that's where you're going to get movement in a joint. So most of the time when we're talking about air sealing and building efficiency, we're usually talking about sealants that have a pretty high movement capability.
Is this kind of information right on the label?
Some it is, some it isn't. If you look at some of the sealants, you can look, and it'll give you the ASTM design testing information. It might refer you to their website to pull that. You can't always just get it right off of the tube of sealant. You may have to look up the manufacturer's information. And if you're like me, you can't read put the lettering so darn small on those, you can't read them anyway. So I usually have to look them up. So just a couple examples of joint movement and why it's important that, depending on what we're using and where we're putting it, that we use the right sealant for it. A joint can move basically in all four directions, and it can move in those directions at the same time. And so, again, we'll talk a little bit more about it, but especially when you're looking at dissimilar materials that might be expanding and contracting, or if you've got a building that moves, that cycles over the seasons, and having a high quality sealant with good movement capability can be pretty important. The other thing that's rated through the ASTM standard is the hardness, and it's rated from 0 to 100. The lower the number, the softer the sealant, and this is how it can be penetrated. And usually this is rated, the softer the sealant, usually the more flexible it is, the more movement that it can take. And so again, understanding where you're putting it and the reaction of the building materials and how they're going to affect it can lead you to making choices on getting one versus the other. So then the other one that you've got to look at when you're choosing sealants is the modulus of it, and they're rated as low, medium, and high. And a low modulus sealant usually has quite a bit higher movement capability than a high modulus one. But the drawback to a low modulus sealant is usually they're a little softer, so you may not always want to use them in a finish application where it's going to be exposed. A great majority of the stuff that we use for air sealing is medium modulus. The high modulus sealant is mostly for, what it's used for mostly is in glazing situations, windows and doors, where you can use it for a stopless glazing. The sealant itself can be what's holding the glazing in place. A lot of the newer windows are set up with a very high modulus sealant, but if you use a high modulus sealant in a window that maybe has a wood frame, the wood's going to expand and contract considerably more than the glass is. The glass will not expand and contract at all in reality. So if it's a high modulus sealant and one joint's moving and the other's not, and it doesn't have flexibility, it's a good chance that the joint's going to fail. So a lot of older windows that just have a lower quality sealant on them in a double pane window. If you've ever seen moisture in between the two panes, it's that sealant that fails. It becomes pretty expensive. Just the basic purpose of joints and what they're used for, they've got to accomplish all of the things that we're trying to accomplish. If it's part of an air barrier system, it needs to function as such. We also have to recognize in the buildings that if it's part of our vapor barrier system, it's got to function as such. And just like all the building materials that we use, different sealants have different permeability. But more than anything is accommodating the movement. So we'll just go through some of the things that we see pretty frequently on projects. And I said this right up front at the beginning. The joint sealant that we have on projects, and when you think about it percentage-wise, think of the new Missoula College building, the overall cost of the sealant in the budget for that building is probably a fraction of a percent, maybe 0.1%. I don't know what it is. But if any of that sealant fails, the damage incurred by that could far exceed millions of dollars. So using the right sealant, understanding where to use it is a science, and then the application of it, which you will find as soon as we get out there today, and for those of you who haven't spent much time playing with caulking guns and foam guns, there is a skill and an art to actually applying it properly and getting it properly in the joint, not all over yourself and not all over the rest of the work, and doing it in a manner that it's going to be a high quality lasting installation. The 4 points of effective sealing include proper joint design, proper product selection, proper joint preparation, and then proper application. So again, one of the big failures in Windows that happened when they started the first iteration of high performance Windows is they were using a lot of the wrong sealant with dissimilar materials. So they were having sealant that didn't have enough movement for the expansion and contraction of the windows, and the joint was sealing. So the whole design of the joint, and that's why a lot of the windows have gone to thermal spacers, and they've set up their joint sealing that way. Same thing holds true in whether we're talking about joints between wood and there are ways that even just framing can be designed to make it more effective to be able to air seal it. The other big one is proper product selection. And again, I mentioned there is a big difference that all tubes of caulking might look very similar, but what's inside of them is significantly different. And depending on where you're going to put it, if you use the wrong stuff, it's not going to last. So making sure that you understand where you're going to put it. Proper joint prep, and we'll talk a little bit more about that, and we'll see that when we get outside, but making sure that the joint's clean, free of debris and dust. Sometimes, depending on what sealant you're using, if you're bonding to masonry or stone or different types of material, some sealant requires a primer on it, or you won't get proper adhesion. And then the last part is proper application, under sealing or over sealing. So all these are pretty much actual real world examples and ways that sealants and adhesives fail. First one is debonding. If it completely comes off the surface that it was applied to, and usually this is from poor surface prep or poor application, not enough joint sealant put in, or not cleaning the joint out, lots of debris left in the joint, no priming if it's a sealant that's supposed to be primed. and we're not going to get into using any of that kind of stuff. We're talking more about larger facade building joints and concrete joints and joints on bridges and those kind of things. Most of what we're going to use is will bond and doesn't need any kind of a primer. And again, the incorrect product selection. You know, I've seen, this is just a picture of a building, and it's the right sealant that they used on it, but it would appear on this one that they either didn't get the joint cleaned out or they didn't put enough sealant in, they didn't accommodate for the shrinkage that the product has. They may have put it in when conditions weren't right, it might have been wet. But I've also seen similar joints like this that should have, that's the right sealant, that's MP1, it's concrete sealant designed for exactly what it's used for, but I have seen people put latex caulk in an exterior concrete joint just because they didn't know, because it's in a tube, it must be able to do the job. Adhesion loss is another one, and you can see this one, the whole side of that bond lost adhesion against that window frame. Again, this could be, for the same reasons, it could be poor surface prep. You know, contamination. Also, back onto that window frame, a lot of times in an existing home condition, people will put, in the attempt to try to air seal it, they'll put that caulking right over an existing window, and that window might have a wood frame and paint on that wood frame that's 20 years old. And so it's actually the paint itself that it might, the sealant might adhere to the paint, but the prep was bad. They should have sanded it down, and I think that's probably exactly what happened in this situation. Probably also the wrong material. So the same remedies, make sure the joint's cleaned and prepped. If it's got to be primed, use a primer, tool it in properly.
What would priming consist of? Just some type of liquid that goes in, or?
Yeah, it could be as simple as a regular primer. It might be to seal the porosity of a material. If it's, depending on the type of, and we'll talk a little bit more about each of the types and how they work a little bit better. It might be sometimes with metal, with certain adhesives, they've got to be primed. And priming also, not just, it's not just putting some sort of material on a joint, but sometimes you've got to prime a joint that might be, wow. It might be actually prepping the joint to give it some teeth. You know, again, with metal, a lot of times if it's got a powder coating on it, you've got to scratch that up, you've got to scuff it so that there's actually something to adhere to. So it depends on the material you're using and the material that you're adhering to. It's kind of just like glue, where you want to make sure too that the material itself doesn't pool all of the solids and the solvents out of it and leave a starved joint. So again, knowing your materials, home air sealing, we've got a pretty limited number of materials that we use, so we get away with using fairly standard, a lot of the urethane adhesives. But when you start talking about some other projects in larger buildings, commercial buildings, facade joint sealing, the products can get a little bit more complicated. Basic cohesive failure. A cohesive failure is where the joint sealant just splits right down the middle. It's not an adhesion failure, because you can see clearly in this picture it's still attached to the material that it was applied to, but the joint itself failed. Most of the time this is the wrong material that gets used, or not enough material, inadequate thickness. And again, wrong material that doesn't accommodate the movement that specific joint has with it. and then also something called three-sided adhesion. We'll look at one of the slides we've got coming up in here, really the best way to be filling a big joint like this. It's possible that this joint was actually filled and the sealant pushed all the way against the back side of it, so it's adhered on three sides. Again, another picture of cohesive failure causes poor joint design. And we'll talk about width to depth ratio a little bit, but that's also a pretty big cause of cohesive failure. So remedies: proper joint design, correct product, proper installation. It really, the only thing that, none of this is rocket science. It's like anything else we do in the building industry. You use the right product and you put it together in the right manner. And then the last thing is substrate failure. So, and this is a little bit back towards prepping the joint, making sure that you've got a good, clean prep joint. You can, I don't know if you can see with the light in there, but this is two pieces of concrete that are sealed together in an expansion joint. And for the most part, the joint held up, but the concrete looks like it cracked and crumbled. More likely than not, probably didn't clean that joint out. We'll look at some of the joints that we're using, and even the ones that in basic construction. If you're sealing bottom plates to the floor, or you're sealing around penetrations, and if those joints are filled with sawdust and flakes of wood, and you may end up sealing the joint in, and all you've got to bond to is the loose stuff that's floating in the joint rather than actually bonding to the substrate. Close that for me. Another thing to look out for: improper tooling, and this is both. The picture on the left is both a mistake on the probably on the width to depth ratio, and also improper tooling. You can see that they just gooped it in there and really didn't set it. Kind of coming off on the seam side, you can see those little holes. I guess you can't, my arrow doesn't work. You can see those little holes in here where it's just coming off because they just gooped it in there and didn't set it. We'll show you that when we get outside. And then there's just an example of some tools. And most of what we do for the air sealing, I will tell you that your finger is the best thing to use to set the sealant and give it a smooth finish. If you're talking about larger joints, cosmetic joints and concrete, and you may be using some of the little tools to do that. And last one is non-elastic sealant coatings. So, for example, this is just and I'm sure you've seen this in an older building, schools or concrete block building, and all the joints were sealed, and then they either used a paint or a coating over top of it, but the paint has far less movement capability. So the sealant might be able to move, but the coating can't. So we're not going to do much with gaskets and strip seals, but these are all of the, and I don't have the pictures of them on there with this version of the slideshow, but the things that we've talked about, and you're looking at everything from outlet gaskets to the self-adhesive foam strips, the weather stripping gasket, and these are things that are not what they call field molded. These are factory molded, so you get them pre-made. And I've got an example. We'll see some backer rod and stuff out there when we go outside and start to do our demo. These are the different field molded ones, and this will go quickly kind of through each one of them. The latex ones are, again, usually not sealant. They're it's a caulking material used mostly for the interior, very little movement capability. So if you put latex caulk, straight latex caulk in a joint, and it's a joint that has really any movement whatsoever, probably within just a year or two, that caulking is going to fail. You'll usually have an adhesion failure on one side or the other, and a pretty significant crack. So what we do see a lot of times when we're looking for a paintable is an acrylic latex, and it's still not considered to be a sealant, but it's a modified caulking. It does have a little bit more flexibility, so it's a little bit better for caulking in, and you can have this both in an interior and exterior formula, but caulking in siding joints and trim joints and ones that are actually going to be painted. A lot of the butyls and the rubber type stuff, very good because it does bond to just about anything, but has very, very poor movement capability. So as far as a weather sealing, field applied, it's not very well used. It's the kind of adhesive that you see in packaging, and a lot of times most of the only applications we'll see is in a curtain wall application or rubber adhesion applications. So whether we're putting up a rubber sound mat on an interior partition wall or some sort of exterior weatherproofing with a rubber base, the manufacturer will usually recommend a butyl adhesive, but other than that, not really used all that much. Polysulfides, which almost been replaced with a lot of the hybrids now. They're the ones that were really considered to be the first generation sealants that were far more stronger, had much more movement capability than caulkings, and still used in some of the wet applications. So these are the more of the newer hybrids, and Gary, you're the materials guy. STP, what is that? Do you know that one?
STP?
STP.
What's on the side of Richard Petty's?
It's not a race car. This is no. But it's part of the chemical compound, and what we're seeing now in a lot of...
Obviously, you got to do something with the elastic modules.
It is, yeah. And what we're seeing in a lot of the newer compounds, they are hybrids and they are compounds, and so they're getting some of the best qualities of each of the different types of sealants. So while some of them, like the butyls, have really good bonding ability, they're very non-elastic and they can't be used for certain. They don't have good movement capabilities. They can almost cross those and take the best qualities out of one adhesive and mix it with another. I'm not a chemist, so I don't know how they do it all, but I can tell you that that's why when you go to a good building supply store, the display where you see all the adhesives and the caulkings, and it's a pretty significant display, and they've got a myriad of different products because there's a lot of different compounds that they can put on there. And then what we still use a ton of are the urethanes, and we use them because of all of these reasons. Excellent bonding. They normally don't require a primer unless it's a very, very porous material. Good UV resistance, excellent weathering, and most importantly, they're pretty forgiving when it comes to application. So they're some of the less, the more user-friendly, less susceptible to operator error. And so this is what we see as a base for most of our sealants. And then the last one in the field molded are all of the silicone adhesives, and you've probably all seen 100% silicone, and it is very, very good for an exterior sealant, very waterproof, watertight, good UV protection, really good adhesion. It can actually be used for structural stopless glazing, so it can have direct-to-glass contact. The only real downsides to the silicone are some of the solvents that are in some of the less VOC-friendly ones, and that it is sometimes a little difficult to work with until you get used to it. Usually has a lot lower tack time than some of the other adhesives, but it's a pretty good one. I'm not going to go through this chart. It'll be in the slides if you want to look at it on Moodle, but it's kind of a graphic representation of really looking at the properties on the left of the sealant, everything from UV resistance to paintability, whether it needs primer or not, and then which adhesive is going to be the best fit for that. So again, looking at the type of joint, the type of materials, what you're trying to get the sealant to accomplish, this is a great little cheater tool for you to be able to use that.
Most of the stuff is on the tube, right? So if you know what material you're using and if you want it painted, interior or exterior, it should be like on the tube for you to just read through, right? Yeah,
most of it gives you that, and most of it gives you the basic information: interior, exterior, paintable. We'll see a couple of the tubes when we go out there. Don't forget that the tubes are still put together by the manufacturer, so you have to look at some of that information. But you can glean a lot from the tube, and some of them do have the ASTM testing and types on the back, so you can look at it right when you purchase it and get the right material.
And some have like the movement percentage or factor on them, but not all of them.
A few of them have that, but not all of them. They'll refer you to their ASTM testing data or their website, and you can look it up.
If it's paintable, then does that mean that it will expand and contract without losing its binding ability?
Say that again. If it's
Like you pointed out, the concrete sealant they use, they paint over top of it, and then the paint hardened and caused it to fail. But if it says it's paintable, does that mean that it will still gain its elasticity?
paintable and the movement capability are not the same thing, so they're not directly correlated. Most of the paintable caulkings don't have that much movement capability just because of that reason. But there are some pretty, there are some pretty extensive flexibility in some materials that can be painted or can be, but again, the flexibility of the paint comes into play. Usually, if it's a latex paint, it's going to have more than a 10% movement capability, so it will move as much, if not more, than the caulking. Now, some of the really, there's some stuff that you'll see out there. It's called Big Stretch, and I think that's a brand, but there's a couple other ones that have significant movement capability, and they're designed specifically to use with exterior sidings, and most of those are color matched because they're not paintable, because they do have so much movement capability. So that's why if you go, you can see them over at Voice Lumber or any hardware stores that do have that. You'll see them, they're all specific to colors. All right, so basic stuff, and you'll get to play with this when we get out there, but simple application tips that can make your life far, far easier when you start going out and doing some weather sealing. But buy a decent caulking gun. Those little $2.99 ratcheting caulk guns will squeeze caulk out the end of the tube. They're fine if you're using it for one small little joint, but if you're going to go do an entire house, one, you want one that's comfortable. Two, those little ratchet ones, you have to get to each one of those ratchets before it locks, and so you're going to get that much play in the Traveler, so it's going to give you that much caulking. So you don't have precise control, and it doesn't stop, and that's why at least a basic dripless one, they have variable speed, battery-operated ones, and especially if you're doing a lot of this work and you're doing a whole house, I can tell you that trying to squeeze the caulking gun for 6 hours a day will give you carpal tunnel syndrome in a hurry. So regardless of how much you're going to do a clean job so that you don't make nearly as much of a mess and you don't waste a bunch of caulk, getting a good gun is important. Know the limits of your material, and this is one I see a lot of times, is you've got to kind of evaluate what you're trying to fill. If you've got a caulking joint that's bigger than your thumb, not only is it going to take a lot of caulk, but more likely than not, it's going to be difficult to get it to look good, it's going to be difficult to get it to adhere, and as that moves and the material shrinks, it's probably going to, either you're going to have a cohesion break or an adhesion break. A lot of the caulking manufacturers will tell you that you can effectively seal a joint up to about an inch wide. I usually say 1/4 to 3/8 of an inch. I'm much more of a fan of moving on to the urethane spray foams. But that being said, for big gaps, you can use backer rod. And one of the things I mentioned earlier, the joint failure occurs because there's too much material. And it's not, sealant really isn't necessarily designed to fill the whole gap and the whole crack. So this is an example just of a larger gap where you're using backer rod in there first, and then putting your sealant on top of it. When you're doing a bigger joint like that with backer rod, and a lot of times maybe on an exterior, you might be doing this on the exterior of the house in certain places, always think of that joint, tell you to think of it as the hourglass shape. So if you can see that joint like an hourglass laid on its side, what you don't want to do is put the backer rod in, not get your sealant to go fully down the diameter of the backer rod, or you don't want to mound it up. So that's just proper installation.
So your backer rod shouldn't be flush.
No.
Joint like the previous one, it needs to go down in.
No, you're going to set it down in so you can get a good amount of sealant in there and make a good flexible joint. If you've got that same situation on a 90 degree or a corner, you can do the same thing in this, what's called a fillet joint, and again, just not using the sealant as the sole source of filling that gap, but putting the backer rod in. And I'll show you the backer rod when we get out there. It comes in a lot of different diameters, and so you want to use a diameter that doesn't necessarily, you don't have to jam it into a crack, but you want it to fit in there snug so that when you push the sealant against it, it's not going to move through. And you definitely don't want it to be too loose in there. The other thing, and we'll go through this a little bit outside when we look at our joints, prepping the joint is pretty important, and whether, depending on what you're trying to do, using a brush, putty knife, compressed air, especially going into older houses, you don't want to go in, and if you've got, maybe somebody did some air sealing in it 5 years ago, 10 years ago, 12 years ago when they built the house, they may or may not have used the right material, they may or may not have installed it properly, but you don't want to go in there and just go over top of that if that's starting to lose adhesion or it's cracking or shrinking. You want to pull it out. You want to prep the joint so that you get good adhesion and then that you actually accomplish what you're trying to do. So I mentioned, this is just another example, I mentioned the width to depth ratio. And you really want to try to keep the width of your crack no more than twice the depth. And so, for example, if the manufacturer says that it will be effective in cracks up to 1 inch, you really don't want to have more than a half an inch deep on that sealant. Again, gunned at midpoint, so you don't necessarily want to put your caulking gun in and tilt it to one side and just push it up against one side. You always really try to lay it in the middle of the joint and then set it. And depending on what you're doing, again, for most of what we're going to do, this is your setting tool, your finger, and we'll have, well, I'll show you in just a minute. Both in how much you use and how you prep your gun, and we'll go through this when we get out there, it's far harder to take sealant out of a joint than it is to put a little extra in, and it's far harder to make the hole you cut on your tube smaller. But it's quite easy to make it larger. And I see that a lot of times with, you can see the joint on the right, they just, looks like they cut the tube off right next to the edge of the, or cut the tip off right next to the edge of the tube and put about a 3/4 inch bead of caulking in a hole that needed about a 3/16 inch bead. Yeah, so nothing can be more frustrating than cutting open a tube of caulking, cutting the hole too big, and then realizing that you can't use it, or you put it on so thick that you are making a mess. Always keep cleaning as you go. It's the other thing I see a lot of times when people start caulking, and you'll get the feel of it once you start using it, and you'll start to learn how fast you have to move your caulking gun along and how hard you have to squeeze the trigger to get the right amount to come out. But still, sometimes you're pushing or pulling caulking, and if you let that build up on the tip, it can do a couple things, and it can dry really quickly, and then it starts making marks in your joint that make it harder to tool, or it can just become like a dam and start pushing. So both for your hands and your finger that you're going to use for your setting tool and for your gun, I always have a small bucket of water somewhere and a damp rag and just keep wiping constantly. It's just far easier. So again, this is going to be and we'll get out there, and I've used some setting tools and stuff in the past, and I've never been really happy with them. And back to where I said that when it comes to air sealing like this, there's a little bit of an art and a science to it. Once you start to practice, you can actually feel, if you're setting the joint with your finger, you can actually feel sometimes where it may compress down into the joint, and you may not have enough caulking in there, and you can go back and put a little in, or you might feel where there's too much in there. Then you can add some more pressure and squeeze that down out of the way. So you kind of get the feel for it after you do it for a while, and which you can't do with a setting tool. But you'll play with it. And I guess the last thing is, don't be this guy. I've seen this guy on my job site before. And even though caulk and air sealing is cheap, you don't want to have to be wasting it. So, any questions, comments, thoughts? And what we'll do is take a quick break, and then we'll head out, and we're going to play with we'll go through, and I'll show you some of the tools, and then we're actually going to do a little bit of air sealing on the tiny house that these guys have been building out there. Sound good?
When do you want to propose
I don't remember. What's the date we put on that? Let me try to shut this thing off here.